Hello and welcome. Today's presentation is brought to you by Science Visualized, and today we're looking at alkanes. Alkanes contain carbon-hydrogen bond, so carbon-hydrogen, no double bond or no triple bond. The simplest example of alkane is this one here, which has carbon and 3 hydrogens, also written as CH4, and the name for that is methane. The formula for alkane is CnH2n plus 2. So in this case, n is 1, so that will be C1, and then H into 2n, so that will be 2 times 1 because n is 1, and then plus 2, so 2 times 1 gives you 2 plus 2, that gives you 4, and therefore the formula for that is C1H4. We usually don't write a 1, and that's methane. Now, if n is 2, then the alkane for that will be C2H. 2 times 2 is 4, plus 2 gives you 6, and that can be drawn as 2 carbons, and then carbon makes 4 bonds, so that means each carbon is connected, these other carbons are connected to additional hydrogens, and if you count the number of hydrogens, it's going to be 6. So you have 2 carbons and 6 hydrogens. And the name for that alkane is called ethane. Next, we look at if n is 3, then it will be C3 and then H2n. So 2 times 3 is 6 plus 2 gives you 8. So C3H8, and therefore you're going to have 1, 2, and then 3, the third carbon with a hydrogen. And the name for that is propane. We can also use skeletal structure for this. Let me just label them. So that's carbon number 1, number 2, and number 3, and therefore it's going to look like that, where that's the first carbon, second, and third. The rules for skeletal structure is that we don't show hydrogens connected to carbon. Each corner and each end means carbon, and you only show hydrogen if it's connected to heteroatoms like oxygen, so OH, NH or NH2, and then sulfur like SH. Next, if N equals to 4, then now the formula is C4H. 2 times 4 is 8 plus 2, H10. So that means we have 4 carbons, and then each carbon makes 4 bonds, so we fill the remaining positions with hydrogens. And if I just label them 1, 2, 3, and 4, you see that the skeletal structure will look like that: 1, 2, 3, and 4. And the name for this compound is butane. For cyclic system, the formula is CnH2n, and now that n is 4, it will be C4H8. And the structure for that is going to be this: 1, 2, 3, and 4. And the name now is cyclobutane. Next, if n equals to 5, and now the formula becomes C5H, and then 2 times 5 is 10 plus 2 gives you 12, and therefore that's going to have 5 carbons: 2, 3, 4, and 5. And the name for that is pentane. Remember, the pentagon has 5 sides, so 5 carbons, pentane. If it's a cyclic alkane, then you lose carbons, or you lose 1 hydrogen on both ends, and then you connect those 2 ends together, and now you end up with a structure like that: 1, 2, 3, 4, and 5, and the name for that is cyclopentane, so you add cyclo. And because we lost 2 hydrogens, then the formula, the formula will be C5H10. So the general formula for cyclic alkanes is CnH2n. For n equals to 6, then the formula for straight chain alkane will be C6H, 2 times 6 is 12, plus 2, so 14. And therefore, the structure for that will be 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. And the name for that is hexane. For cyclic system, the formula is CnH2n, so that will be C6H12. And the structure for that will be this. 1, 2, 3, 4, 5, 6. And the name for that is cyclohexane. For n equals to 7, then the formula for straight chain alkane will be C7H, 7 times 2 is 14, plus 2, H16. And the structure will be 2, 3, 4, 5, 6, and 7. So 1, 2, 3, 4, 5, 6, and 7. And the name for that is heptane. For a cyclic system, the formula is CnH2n. So that will give you C7H14. And the structure will be like this. So 1, 2, 3, 4, 5, 6, and 7. And the name for this now is cycloheptane. For n equals to 8, the straight chain alkane will be C8H, 2 times 8, that's 16, plus 2, 18. And the structure for that will be 1, 2, 3, 4, 5, 6, 7, 8. And the name for that is octane. For a cyclic alkane with 8 carbons, the formula will be CnH2n. And now we know that n is 8, and therefore it will be 2 times 8, which gives you 16. And the shape for that, the structure for that will be this. One, 2, 3, 4, 5, 6, 7, and 8. And the name now is cyclooctane. For n equals to 9, then the formula will be C9H, 2 times 9 is 18, plus 2, 20. And the alkane with these 9 carbons will have this structure: 2, 3, 4, 5, 6, 7, 8, and 9. And the name for that is nonane. The cyclic alkane with 9 carbons will have the formula CnH2n, which will mean C9H, 9 times 2 is going to be 18. And the name for the cyclic structure with 9 carbons is cyclononane. It starts becoming complicated drawing cyclic systems with more than 7 carbons. Now for n equals to 10, then it will be C10H2n, that's 2 times 10 is 20, plus 2, it will be 22. And therefore we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you add one more, 10. For cyclic system, it will be C10H20, and the name for the cyclic system is cyclodecane. Remember, a decade is 10 years, and this other one will just be decane, the straight chain. With n equals to 11, so it will be C11H2n. So 11 times 2 is 22, plus 2 gives you 24. And therefore, you're going to have an additional carbon here. So 10, 11 as the structure, and the name for that is unidecane. For cyclic system, it's going to be C11 and then times 2, which will be H22, and the name for that is cyclounidecane. Lastly, for 12 carbons, so C12, it will be, for H, it will be 12 times 2, which is 24 plus 2, gives you 26, and therefore we add one more carbon there, 12, and that will be the structure, and the name for that is dodecane. The cyclic system will be C12, H24, and the name will be cyclododecane. Thank you very much for your time. If you enjoyed this presentation, comment and also support the channel by subscribing.